Welcome back. Well, before we learned about using the leaf method for prime factorization, greatest common factor, and now we're in the lesson of square roots. Now we're going to find out how do you add and subtract square roots. Well, the radicands must be the same in order for you to add or subtract. What is a radicand? The radicand is a number or the letter inside the radical. So for example, the square root of a plus the square root of a is the same thing as 1 square root of a plus 1 square root of a. Notice that there's an imaginary 1 that you have to pay attention that it exists in there. So there's a 1 here, right? We didn't see it, but there's a 1 there, and that's why I put it up here. But most likely they're going to give you this, right? They're going to give you square root of a plus the square root of a. Okay, so now that the radicands are the same, you could add the coefficients. So 1 plus 1 is 2 square root of a. Now, this is the same thing as if you were adding x plus x. Now, most likely you know that when you have an x and you have an x, you keep the same variable and you just add the coefficient. And therefore this becomes 2x. So pretend that the square root of a is just x, and then you just add them. So 1 plus 1 is 2, and you keep the square root of a. So let's do another example. 3 square root of b plus 1 square root of b. Alright, you have the same radicand, therefore add the number in front. So 3 plus 1 is what? 4 square root of b. Okay, now notice, here, 4 square root of b plus square root of c, these radicands are not the same, so you can't add them. But this b and that b is the same, so therefore you could add the numbers in front. So what is 4 plus 3? That is 7, and you keep the same radicand, square root of b. And then you have plus the square root of c, right? Okay, so let's look at a couple more examples. Now let's look when you're subtracting and adding them together. Alright, here, notice that these guys are square root of a and square root of a. Therefore, you could subtract the numbers in front of the radicand. So, what is 3 minus 1? There's a 1 here. So 3 minus 1 is 2 square root of a plus 3 square root of b. Okay, now again, number 5 and number 6 are a little tricky because notice that this square root of 2 and that square root of 2, they're the same, right? But then the square root of 8, you just can't assume that you can't add them together. You have to simplify the radicands as well. Now, in a previous video, I taught you that you should memorize these numbers over here, which are perfect squares. And we had to see, is 8 a perfect square? Well, let's look here. 8 is not a perfect square, so we have to do the leaf method. So let's do the leaf method for 8. So for 8 becomes 8 is divisible by 2, 4 times. 4 is divisible by 2, 2 times. And 2 divided by 2 is 1. So you're going to circle the pairs. And then therefore this is the same thing as the square root of 8. Is the same thing as 2 square root of 2. And notice that square and that square root cancel. The square goes outside and therefore becomes 2 square root of 2. Now notice how now it's becoming very similar, right? This is the same thing as plus 2 square root of 2. 3 square root of 2. I'm just writing it down. 10 square root of 2. And notice now the radicands are the same. So therefore you could add the numbers in front. So 10 plus 2 is 12, and 12 plus 3 is 15. 15 square root of 2. That's what you have. So that's the answer for this one. Okay, so notice the bottom one now. We have 3 square root of 3 plus square root of 27. The 27, you notice here, is not a perfect square. So you have to do the leaf method again. Let's do it together. 27. 27, you have to divide it by the prime numbers. So 27 is divisible by 3, 9 times. 9 divisible by 3, 3 times. And 3 is divisible by 3, 1 time. Notice that the 3 and the 3 are a pair, and therefore this becomes the square root of 3 squared times 3. The square and square root cancel. The 3 goes outside, and therefore this becomes 3 square root of 3. So this guy here is 3 square root of 3 plus 3 square root of 3. Now notice here we have the square root of 27, which we found out was 3 square root of 3. But remember, once the number is outside, it multiplies times the number outside as well. So it becomes 4 times 3, that becomes a 12 square root of 3. Therefore, you have to look at the radicands now. I have to simplify the radicand until you have the lowest terms. And here you have square root of 3, square root of 3, and square root of 3. Because you have the same radicands, you could add the numbers on the top, in front. 12 plus 3 is 15, 15, 16, 17, 18. So you have 18 square root of 3. So this is how you should add and subtract square roots. Now, in the following videos, I'm going to show you how to do a little bit more simplification. I'm going to wrap up with square roots and with LCD.